and welcome back to the Countering Climate Skepticism podcast. Each week we tackle a different climate skeptic argument from different levels of the climate denial ziggurat. If you want to know more about that, we have a specific episode explaining what the ziggurat is in detail. My name is John Rainier and I'm joined by my co-host Mark Prosser. How are you doing today, Mark?
Not bad, John. Enjoying Corona here.
You're drinking a beer?
Yeah. I've always been drinking a beer every week when we have these chats. You know, I have my Uber-sized Corona here.
It's like 8:30 in the morning, Mark.
I know. But, you know, I just figured it would make me, I don't know, a bit more fluent and, I don't know, personable, I guess. I don't know. A bit strange, I'll admit. But yeah, it seems to work.
Good old breakfast beer with John and Mark.
I assure you I have no problem with alcoholism, luckily. This is probably...
Says every alcoholic everywhere.
No, but I really mean it. Like, you know, I drink so little alcohol generally. So I feel like I'm pissing into the wind trying to convince you.
Yeah, don't do that either. Yeah.
Yeah. I'm sure you have experience of doing that, being an outdoorsy type. Yeah. So apart from my beer drinking habit at 8 o'clock in the morning, this week there was a super big storm passed through the UK.
Yeah. Was it Storm Kieran? Was it?
That's correct. Yeah. So it had like so they talk about storms in terms of their intensity a lot of the time by the pressure in the middle of them, and the lower, the more severe the storm is usually. And this one had a pressure of 950 millibars, and that's really, really low. And so it was a really, really strong storm.
Where in the country did it hit the hardest?
So it kind of, as far as I was aware, it sort of, from Devon, sort of going across the south of England. I think it tracked across there, and it's funny. On was it Thursday? I woke up and I was expecting there to be like loads of wind. Yeah. And there wasn't. I was like, what is this storm then that they're predicting? But basically, we were in the middle of the storm, and in the middle, it's all calm.
The eye of the storm, yeah.
Exactly, yeah. So it's kind of a bit surreal in that respect. But like in north of France, you know, the winds were like swirling around this sort of center point where we were, where there was no activity. Yeah, very, very strong winds, and probably. Like where you were was the strong winds?
Yeah, well, we got away in our van. I mean, what days was it that it was the worst? Because we were away, so I was kind of out of touch with the news and stuff like that.
Thursday, maybe. Wednesday.
We were up in Birmingham on Thursday. Like to be honest, just seemed like a blustery day. To be honest.
Okay.
The weather's rarely like super nice in Birmingham anyway. So,
right.
Just a different type of shit compared to the usual.
Yeah, maybe the wind.
So it didn't hit us that bad.
Okay, well that's good to hear. I think some places in the country have been affected, but yeah, all the weather geeks in my department at Reading were very excited about this.
Yeah.
Super low, so the atmosphere above us was a bit lighter than it usually is. So usually it averages about 1,000 and it dropped to 950. So like literally the column of air above you was less because you're in the middle of a storm. So that's crazy. Very exciting for the physics nerds.
Yeah.
And you said you were away gallivanting around the country in a van for the half term.
Yeah, we'd gone away for 5 days, just kind of exploring around in the countryside. Went through Wiltshire and Gloucestershire and areas around Somerset, things like that.
Okay.
Yeah, so we headed down your way. Are you in Buckinghamshire at the moment? Are you? Or...
No, Reading. Well, it's kind of similar, I guess.
Yeah. And we then kind of headed across through the Chilterns. Through to the North Wessex Downs, so it's some lovely wild rural countryside to be spending a few nights in, which is nice. I mean, we did have some pretty terrible weather. We got hailed on when we were walking into Glastonbury, so maybe we did catch a bit of this storm. But when you're living in a van, like you kind of just bad weather just is part of the course. It rained the whole week anyway.
Yeah. Did you sleep in the van as well, or do you?
Oh yeah. We sleep in it every night. finding spots to wild camp.
Was it relaxing, the whole thing? Or?
Yeah, it is nice to get away, because obviously we spent a whole year doing it last year, so it feels very, very freeing to get away for a few days and spend your time in the van. I highly recommend it. Go and live outdoors in your van as much as you can. Well, I say outdoors. We're not outdoors at all. We're in a vehicle.
If I get the opportunity, I'll snap it up.
Okay, so in today's episode, this is going to be our third podcast episode looking at the second level of the denial ziggurat, which is the level which states that the climate is warming, but that it's not us that's doing it. So just to recap, in part one, we looked at what factors mainstream climate scientists consider important in explaining the rising temperatures, that CO2 is warming and that aerosols from fossil fuels burning are cooling. Then in part two, we looked at why certain alternative explanations don't work, looking in particular at the sun and volcanoes. In this episode, in part three, we're going to be looking at a couple of criticisms that skeptics level at the CO2 explanation for climate change. We hope you enjoy. So take us away then, Mark.
So first of all, John, just as a sort of recap of last week, do you remember any of the 4 bits of evidence that preclude the sun being the cause of climate change?
I reckon I remember a few of them. So that only the lower atmosphere is getting hotter, not the whole atmosphere. The poles are warming faster than the equator.
Yeah.
Winters are warming faster than summers. I can't remember what the last one was.
Oh, right. Okay. Yeah, that was, you thought you were going to get them all there. Nights are warming faster than days.
Yeah, that's it.
Yeah. Very good. Very good. And there were also, in last week's evidence, we talked a bit about volcanoes and why volcanic CO2 also wasn't a good explanation. Do you remember the 3 bits of evidence we mentioned for that at all?
The only one that springs to mind is that it was the wrong type of CO2 in the atmosphere. Was it that C13 comes from volcanoes and that's not what we're seeing in the atmosphere? Is that right?
Yeah, so it's kind of along those lines. Essentially, plants tend to preferentially take up carbon-13, so carbon-12 is the main one.
Oh, right, okay. Yeah.
And so if you burn lots of plant matter, which is essentially what we're doing with fossil fuels, you end up getting a reduced amount of carbon-13 in the atmosphere. So essentially, yeah, you were right that the CO2 ratio of these different isotopes, carbon-12, carbon-13, is changing, and that can only be as a result of fossil fuels. So essentially, when I say 3 bits, there were 2 isotopes. Carbon-13 is getting more dilute, and carbon-14 is getting more dilute. And carbon-14 is interesting because it's radioactive and it decays.
Okay.
And so in fossil fuels, which have been buried for millions of years, it's all gone, basically. And so we're seeing a drop-off in carbon-14 in the atmosphere, and that's consistent with burning something that's or that the carbon dioxide is coming from something that's very old. And the third piece was that oxygen in the atmosphere is ever so slightly declining. And that is because we're burning carbon. It's combining with oxygen to become CO2. So that oxygen is being taken out of the atmosphere. Today, a bit later on, we'll be adding another 2 bits of evidence to that point towards it being fossil fuel CO2. And not some alternative explanation like outgassing from the ocean. Okay, so to kick us off, we're going to start with the more boneheaded side of the climate denial playbook. So an argument that they give sometimes is that CO2 is not increasing. So CO2 is not increasing. Well, okay, as usual, when we hit something like that, we have to look at the data. So do you have, so we've got a link which we'll put in the show notes, co2level.org. Have you got that up, John?
Yeah, I've got that here. So is this global CO2 levels, and it shows a graph measuring the carbon dioxide parts per million compared to the year, I presume that is.
Yes, it is the year, yeah. that's correct. And so what level was what has happened to the carbon dioxide concentration over time?
It's going up massively. So it's been climbing pretty much since the start of the 1800s, but really starts to pick up probably from around about 1860 onwards. But then from the 1960s onwards, then it shows a very, very steep incline very rapidly.
Yeah, that's correct. This is a good site, actually. If you sort of scroll down slightly from here, you can see underneath the graph, there's methane levels, nitrous oxide levels, oxygen levels, temperature records, sea levels. So it's a good one-stop shop for if you just want to see, for example, what these other indicators of the climate are doing. So methane and nitrous oxide are the other two big greenhouse gases. So it's like the trio of carbon dioxide, methane, nitrous oxide. Yeah.
Just out of interest, so this tracks all the way back to the year 1000. Where are they getting the data from for that?
So you can get you can drill down, for example, in regions of the world like Antarctica and Greenland, and you can pull out like an enormous 2-kilometer long sort of ice core. And in this ice core, it sort of traps little pockets of air from different times in history. And the deeper you drill down, the further back in time you can go. And I think there's other methods as well, but that's one of the key ones.
Okay.
So yeah, it's good old geology, or glaciology rather. So this global average level, which John has just described for us, which takes data from all around the globe and gives us a global average of what carbon dioxide is doing on Earth in the lower atmosphere. If you'd like to see more regional CO2 levels and to see all the locations around the world where CO2 data is recorded, you can follow the below link, which I'll put in the show notes. I guess we're not going to look at it for now because it's a bit, it's not. So it's for viewers who are interested to have a look. But it basically shows that we're collecting carbon dioxide measurements at more than 100 places around the world, and we don't even really need that many places because carbon dioxide is well mixed, meaning that it's more or less the same everywhere on Earth. You know, it's not like water vapor where there would be much more of it in some places rather than others. It's about 420 parts per million on Earth at the moment, and it varies a little bit depending where you are, but it's kind of between 400 and 430, say. So yeah. But we do record it in many, many different places. Okay, so once you acknowledge that the CO2 rise is incontrovertible, there are various other arguments that the skeptics like to level against CO2 being the driver of the temperature change we've seen. We will look at two this week, which boil down to man-made CO2 is pitiful in the grand scheme of things, and the rise in atmospheric CO2 is natural and can't be causing the warming that we've seen. Okay, so to put more explicitly the first of these arguments, the amount of CO2 humanity emits each year is dwarfed by the amount released by natural sources. Okay, so in order to debunk this particular skeptic claim, I have to tell you a little bit about something called the carbon cycle. In the carbon cycle, carbon gets cycled around different reservoirs, such as the atmosphere and the ocean. But first, I'll need to introduce you to a unit that we use to measure the amount of carbon. It's called the gigaton, so a gigaton of carbon. Do you happen to know how many tons in a gigaton?
Would it be 1,000 tons?
So it's actually 1 billion tons.
Billion? Bloody heck.
Yeah. And so 1 billion is 1,000 million. It's a heck of a lot, you know. Okay, so if I tell you that, you just think, oh, that's a big number. Like, it doesn't really mean anything to me, like 1,000 million tons of carbon. It's like, you know. So to give you a bit of a perspective on that, a good number to remember is that each year humanity emits about 9 gigatons of carbon into the atmosphere each year.
So when you say humanity, are you talking about through fossil fuel burning and things like that, or is that also including us breathing?
So not including us breathing. It's I'll get onto that in a minute, but it's yeah, you're right. It's fossil fuel burning, cement making, and land use change. So if we sort of chop down a forest.
Oh right. Oh, okay. So it includes the deforestation as well. Okay.
Yeah. So human activities aside from us merely existing and respiring. But yeah, it's a good point. So now that I've given you a sense, so 10 gigatons or 9 gigatons is the amount humanity emits with its, industrialized society. So I'm going to give you I'm going to list off 5 reservoirs in the carbon cycle and give you an idea how much carbon is stored in them at the moment. And so I'm going to do this in descending order. So at number 1, we have the ocean. And in the ocean, a whopping 38,000 gigatons of carbon is stored. Next down, we have the fossil pool, which is where we dig up our coal, oil, and gas from. So all of that underground, there's about 10,000 gigatons of carbon in that reservoir. In the soil, another 2,300 gigatons is stored. And then in the atmosphere, we have that 400 parts per million. If you work that out, if you take the whole atmosphere and you work the mass of that carbon dioxide, it comes to 800 gigatons.
All right.
And then in all the plant biomass, so all the forests, that sort of thing, there's about 550 gigatons of carbon. So that's the carbon reservoirs in a nutshell. So like I said before, humans emit about 9 gigatons a year from fossil fuels. But hang on, each year, animal respiration and decomposition emits 60 gigatons to the atmosphere from the land, and a further 90 gigatons of carbon per year from the ocean to the atmosphere. And on top of that, land plants themselves respire another 60 gigatons per year.
Significant amount, yeah.
Yeah, definitely. And so together, that's 210 gigatons per year is going into the atmosphere from the land, from the ocean, etc. Which means that our 9 gigatons, what does that correspond to? Like 4% of all emissions are us. So any thoughts here, John? Surely this means that human emissions are insignificant relative to these much larger natural fluxes each year. What do you think?
To be honest, when it's spelled out like that, it sounds like quite a reasonable argument.
It does, doesn't it? And it's all true, but you've got to be careful here because it's true, but it's incomplete. So the denier, when they present this to you, is cherry picking. So they're just telling you the things that support their argument, and they're missing out crucial things that might conflict with their argument. So what they're not mentioning is that every year, sort of the plant matter on Earth photosynthesizes and is giving out is taking in from the atmosphere 123 gigatons of carbon.
Okay.
So 123 gigatons from the land biosphere, so things like forests, 123 gigatons is going in. And then in the ocean, there's also sort of plant life in the ocean is photosynthesizing, and that's pulling another 92 gigatons back into the ocean from the atmosphere. So the fluxes operate in both directions.
And how big an impact on that amount of photosynthesis occurring does deforestation have? Is deforestation in the Amazon, is it having a significant impact on the amount of photosynthesis that is occurring worldwide then?
That's an interesting question. I think actually, one of the effects of climate change is that if you sum up all the plant matter on Earth, the amount of plant matter is actually increasing because the amount of CO2 in the atmosphere is increasing, because CO2 is kind of like plant food. And so it's you're getting, if anything, an increase in the amount of photosynthesis. Okay. Despite the amount of forest being cut down However, the forest getting cut down is resulting in a sort of an increase in sort of man-made fluxes of CO2. This might all become a bit clearer, when I go a bit further with the explanation. So essentially the skeptic has mentioned all the fluxes going out into the atmosphere, but they don't mention the fluxes going back in the other direction. And so when you do that, you see that like they kind of cancel out all the natural ones. So all the animals respiring and then all the plants photosynthesizing kind of cancel each other out. And then what you're left with is the human emissions, which don't have that opposite flux back.
Yeah.
So if you get sometimes you get like a really stupid climate denial argument, which is, well, like we all humanity exhales carbon dioxide, and maybe we should stop breathing if we care about climate change. Does this?
No, just the climate deniers, yeah. They'd be doing the world a favour if they stopped breathing. Yeah.
That's very funny, but a bit mean, John. A bit mean. I mean, like they deserve to get a clap round the head, or not, or maybe 2 clap round the head. But yeah. But do you see why is it okay that we can breathe out carbon dioxide given that argument?
Because we're included within the natural biosphere, I presume. So it means that our carbon dioxide is being reabsorbed by photosynthesis.
Yes, exactly. You've got it. So it's kind of beautiful when you think about it. Animals on the land and the ocean breathe in O2 and breathe out CO2. Plants breathe in CO2, for want of a better word, and exhale oxygen. Although plants don't really do that, but in the photosynthesis context. And although these annual fluxes are vast and bigger than the human ones, they almost exactly cancel each other out. Burning fossil fuels is different, though. We're pulling these from deep reservoirs within the Earth and burning them into the atmosphere. Ain't nothing cancelling out those extra 9 gigatons that we throw.
Yeah. So it just shows how finely balanced everything is, and that the human impacts do sway things quite significantly.
Exactly. Yeah, there's this nice equilibrium in nature, and we've perturbed that. Exactly. If anyone was paying particular attention, they might have noticed with all the numbers in terms of the fluxes I gave out there, that the CO2 fluxes into the atmosphere was slightly less in total than those out of the atmosphere. So the natural fluxes are 210 combined going into the atmosphere, but 215 are coming back out. So more is being taken out than is being put in by the natural fluxes. This is because the land and the ocean are doing us a huge favour and mopping up about half of the CO2 which we dump into the atmosphere by burning fossil fuels. If they didn't, levels would rise even faster.
Yeah.
So currently, like every year on average, I think it's something like the amount of carbon dioxide in the atmosphere increases by 2 parts per million. If the atmosphere and the ocean weren't doing this for us, they might increase by 4 parts per million.
Right.
So thank you, nature. Yeah, but even though they do this for us, about half of the 9 gigatons that we emit doesn't get mopped up. And that raises the concentration of CO2 in the atmosphere. So that's the trick that's being played on us when the denier talks about these insignificant in the context of these vast fluxes.
Yeah.
You just have to know that they're missing stuff out, But it's also nice when you know this extra bit, and it just completely confounds them, and they're just sort of drowning in their own terrible argument after that, which is quite satisfying when you when you encounter this one. Moving on to the second anti-CO2 argument we're going to look at today. It's the argument that the CO2 rise we see today is an entirely natural phenomenon.
Right.
So there's a link here which I'll put in the show notes.
CO2 lags temperature intermediate.
Yeah. So do you see like a graph with blue and red lines,
Yes.
time series?
Yes.
Yeah. So can you describe a little what you think you see?
So we've got temperature in degrees centigrade, going from -10 all the way up to +25. And along the bottom, we've got age in thousands of years before the present.
Yeah.
And what we're seeing is, so what's the red line? Oh, okay. So the red line is temperature. And we've also got the blue line, which is measuring CO2 levels in parts per million. And we basically see it's kind of oscillating up and down, and they seem to almost be mirroring each other. So as temperatures rise, we also see CO2 go up, and then as temperatures fall, we also see CO2 going down. And that seems to be fairly consistent. The larger the temperature increase, the larger the CO2 levels increasing. But we also are seeing that although there's been a kind of similar increase in temperature recently, the CO2 levels have shot through the roof.
Yes. So they're what? I think it's sort of at their maximum, they were 280 parts per million in the past. So the previous 10 times. So there's this cycle has happened in the last million years. It's the temperature's gone up and down about 10 times, which I think you mentioned. But so the CO2 never has gone above 300 parts per million. And now we're, north of 400 parts per million. And it's a stark contrast. So that's the graph we see before us. So it's a bit hard to see in this graph, but because the axis, the time axis, is just so
massive.
squashed. It's like a million years of time you're looking at. But temperature seems to rise if you sort of stretch it out. Temperature seems to rise first, and then carbon dioxide rises.
Yeah.
So what the skeptics argue is, based on this true time series, so it is true that the first thing that happens is that the temperatures rise, then the CO2 rises, rather than CO2 first, then temperature, is that they would say roughly 10 times over the last million years, so the intermediate past as far as the climate is concerned, CO2 rises have been the result, not the cause of temperature rises, and therefore CO2 can't be causing the current rise in temperatures. Do you notice any problems with this skeptic argument on the face of it, or does it sound like it could be true? Or
the only thing I can really think of is it that because we're looking at such a heavily compressed period of time, that actually the effects are a lot more delayed than we're seeing? Is that potentially it? That actually what we're seeing is the CO2 increases are causing the next cycle? Is that potentially it?
It's a good guess, but it's not the main issue with this skeptic argument. So I guess there's two issues with that particular phrasing. So I'll read the first bit again. So roughly 10 times over the last million years, CO2 rises have been the result, not the cause of temperature rises.
Is it like a false equivalence thing?
Yes. So we call this a false dichotomy. So it either has to be this or it's that. You can't have both. And actually, both things are true. So basically, roughly 10 times over the last million years, CO2 rises have been the result, not the cause of temperature rises. That's true. And therefore, CO2 can't be causing the current rise in temperature. No, hang on. It's not either or. Both are true.
Yeah.
So basically, CO2 can cause temperature rises, and it can also be the result of a rise in temperatures.
Okay.
So both can be true. So I'll explain. It might not be 100% clear now, but as we go on, hopefully it will become clear what I'm talking about. I think at this point, just a quick refresher Do you remember? I think we spoke about this a little bit on episode 2. But do you happen to remember, John, why in the intermediate past of the last 1,000,000 years, why did the climate go warm, cold 10 times? Do you remember the cause of that?
Was it natural fluctuations in global temperatures? So was it like mini ice ages occurring?
Yeah, sure. So there were, yeah. So that's true. But do you remember like why? So if currently it's because we're pumping carbon dioxide into the atmosphere, that's causing the warming. What was causing the warming and the cooling about every 100,000 years? Do you happen to remember? No worries if not.
The only thing was it possibly related to the sun?
Kind of indirectly, yes. Basically, the Earth's orbit itself.
Oh yes, yeah.
Changes. So it becomes sometimes a bit less circular. There are 3 main types of ways it changes. We're currently inclined at 23 degrees. So we have our seasons because of that. But this axis wobbles a little bit. So it goes from between 22.5 to 24.5. So sometimes it becomes more pronounced and less pronounced. And also the at the moment the North Star is the direction of north, but every so often over a long period of time this axis itself still remains at like about 23 degrees, but it flips.
Okay.
Not suddenly, but so there's all sorts of changes in the Earth's orbit, so it doesn't always remain the same. And these changes in the orbital dynamics mean that in some phases, the northern hemisphere is getting slightly more sunlight in the summer, and that can set off a slight warming of the ocean. And the ocean itself, over a long time period, will warm up slightly. And because it is slightly warmer, a warmer liquid, like we were saying with the beer experiment, I think we mentioned a while ago, a warm liquid can't hold as much carbon dioxide.
Right, yeah.
So it releases a bit of its carbon dioxide to the atmosphere. Carbon dioxide, we know, is a greenhouse gas and then causes further temperature rise. So you get the initial warming to trigger it off. That then leads to the ocean emitting carbon dioxide. That then feeds back, and you get then this quite, by geological standards, a fast rise in temperature.
Yeah.
So both are true. So the CO2 is helping the warming, but it's also caused by the initial warming. So if that makes sense.
Yeah.
So if the skeptic insists that for the previous 10 times it's been warming first and CO2 rise second, how can we be confident that this time the increase in temperatures we're seeing, the increase in CO2 we're seeing isn't a result of the rise in temperatures? So it's been like that for the past 10 cycles. You know, why are we so certain that it isn't the same now?
Yeah.
That it's not. Why are we so certain that it's carbon dioxide which is causing the temperature rise? Well, first of all, these orbital cycles are very predictable. And if we look at where we're at now, we should be heading into an ice age.
Right.
So we're on a downward trajectory, yet despite that, we're getting warmer. So just the timing is out as far as the skeptics are concerned. But imagine if, hypothetically, we were in the same situation with our warming, but just thousands of years later, when the orbital dynamics sort of indicate that we should be warming. So maybe the skeptic would have been on firmer ground to argue this because, you know, we would be in the right phase. What evidence could we throw at the skeptic, even then, to refute this CO2 from the oceans theory? Any ideas, John? Just a hint would be to think back to when we were talking about volcanic CO2 and why it wasn't likely to be volcanic CO2.
So would it be by measuring the type of CO2 going into the atmosphere?
That's correct, yeah. Or you don't even have to necessarily measure the type that's going into the atmosphere. You just have to have like a time series of measuring the atmospheric concentration of these other isotopes. for example, carbon-14, which tells us that it should be very ancient carbon. But that's exactly it. Also, like we said before, you wouldn't be getting, if carbon dioxide was being released from the ocean, you wouldn't be getting atmospheric oxygen depleting as well. But in addition to these arguments, which are fine on their own, and you'd be perfectly able to rebut the skeptic if they were on that basis alone, there's a couple of points you could raise. Have you heard about a phenomenon called ocean acidification, John?
No, I don't think so.
Okay. So I've got another link here. The link will be in the show notes. Have you got it open?
So ocean acidification, global warming's evil twin. Is this the one?
That's the one, yeah.
Okay, yeah.
So let me just
the graph again.
Yeah, sure. Let me just explain what ocean acidification is first, maybe. When CO2, so CO2 dissolves in the ocean and the surface of the ocean, and it forms like a really weak acid when it does that through, it's called carbonic acid, and this then lowers the pH of the of the ocean. So basically, it's becoming more acidic. And so this is a huge problem for like life in the ocean. It's not it's not becoming like a strong acid or anything, but it's, like life in the ocean is sort of, it's used to the ocean having a certain pH, and so a change in that is problematic, especially if if you've got some shell on your back, then the extra acidity sort of hinders your ability to make shells. So sea creatures and corals as well. Corals don't like acidity. But yeah, so if we go back to the graph now, what do you see?
Okay, so this is measuring acidity by pH. So we're seeing the ocean at a pH of around 8.10, so ever so slightly alkaline, going down to 8.06. So we're seeing, just a line of best fit showing a steady decline in the pH, moving towards a more acidic pH level.
Yeah, that's correct. And that's over the time period 1985 to 2020.
Oh, wow. So actually over a very short period of time.
Yes. So maybe I think maybe they haven't been measuring ocean pH for as long as they have been measuring atmospheric carbon. So the time series isn't that long, but it's clearly getting more acidic. And that's because you have more carbon dioxide in the atmosphere, more of it gets dissolved in the ocean, and you get acidification. Yeah, so the skeptic argument that the ocean might be releasing carbon into the atmosphere, because there's a lot of carbon there, like 38,000 gigatons. It's the biggest reservoir of carbon. It's even bigger than the fossil fuel reservoir. The idea that, so if it just released like 1% of its carbon, we'd be screwed. Like it would just be so much carbon in the atmosphere. But there's a clever ocean acidification sort of teaches us that more carbon is going into the ocean than is going out of the ocean. Because if the oceans were losing carbon, the trend would be the opposite. Yeah, there would be less carbonic acid in the ocean, and as a result, the pH would be increasing. So it would be becoming more alkaline. We don't see this. So we know from that alone that there's a net flux into the ocean from the atmosphere. Okay. So it's like what I was saying earlier, it's mopping up some of the extra CO2 that we're emitting. But in so doing that, I guess it's good for temperatures, but it's also causing a lot of problems for life in the oceans. Yeah. So that's why they call it global warming's evil twin, another environmental problem. Yeah. So unfortunately for the skeptics, with the recent warming, CO2 really is the cause. There are I've now given you 4 reasons why it has to be old fossil fuel carbon that's doing it. Now, as I said before, the land and the ocean mop up about half of the CO2 we emit each year. However, there isn't a guarantee that they will keep on doing this with the same efficiency for us. The oceans are warming, and warming waters, as we've been saying, can't hold as much carbon dioxide. So the ocean may, unfortunately, as time goes on, get crapper at doing this favour for us.
Yeah, it's giving us like a temporary buffer, but that's going to have declining returns.
Exactly. So yeah, and as they decline, as this buffer declines, atmospheric concentrations will rise faster. So I don't know if they've seen evidence for that yet. You'd have to look into the most recent research, but it's worrying if that starts to happen, certainly.
Yeah.
And so one further comment: the skeptics are just so dead set about it not being fossil fuel CO2, but yet we kind of know how much carbon dioxide gets emitted from all that humanity burns. We know by how much carbon in the ocean is increasing, in gigatons. We know by how much CO2 in the atmosphere is rising. And all these numbers all add up. So we know carbon is getting put here, and we know how much it's increasing in the various reservoirs. This would be one mighty coincidence that these numbers all add up otherwise. And where the hell is this fuck ton of carbon that we are emitting supposed to go, according to the skeptics, who like to argue that carbon in the atmosphere isn't from fossil fuels? But still, they seem to cling to their pet theories. I guess when you don't want to believe something, you ask yourself, must I believe this? To which the answer is nearly always no, because no one is ever compelled to believe anything they fundamentally don't want to believe. That's
good,
just the way it is.
Good philosophical point to end on there.
I try, John, I try.
All right then, so to sum up what we've covered today then. So to sum up, the skeptics' arguments to do with level 2 of the Ziggurat, we've been disproving those arguments, and this is what we've been looking at over the last 3 episodes. So that CO2 levels are rising, that humanity's CO2 emissions are not trivial, that volcanic CO2 cannot be the cause of elevated atmospheric CO2, neither can ocean outgassing of CO2, nor the land biosphere. We've looked at the argument that past warming cycles have been caused by very slow changes in Earth's orbit, and that the sun can't really explain the patterns of global warming we have seen. We've seen that numerous lines of evidence point to the cause being, in actual fact, ancient fossil fuel burning, so it is man-made. Apart from CO2, aerosols produced from the burning of fossil fuels also affect the climate by cooling it, but this cooling doesn't offset the warming completely, therefore we get global warming. Okay, so just to let you know, we're going to be releasing episodes at a slightly slower rate from now on. So once every 3 weeks will probably be the case once we get to this episode being released. And we've been releasing episodes weekly up until now because we've had a bit of a recording backlog. But we'll be these episodes take a fair bit of prep, largely from Mark, not from me. But
that's not true, John. That's not true.
But just so that we don't burn out, we're going to be slowing the release slightly over the next few weeks. So we hope that's okay with you all. So I guess on to our climate good news story next. So a recent study by the UN-backed scientific assessment panel for the Montreal Protocol on ozone depletion substances, quite a mouthful that one, confirms the phase out of nearly 99% of banned ozone depleting substances. So I'm sure when we were both kids, Mark, the ozone hole was the big news around climate change, and it's kind of like faded out of the public discourse quite a bit, and I think that's largely because we've actually been having quite a big impact on it. So it's expected that if current policies remain in place, the ozone layer is expected to recover to 1980 values. So basically the point before the appearance of the ozone hole, by around 2066 over the Antarctic, by 2045 over the Arctic, and by 2040 over the rest of the world. So This has required the phasing down of production and consumption of many hydrofluorocarbons, or HFCs. And while HFCs do not directly deplete ozone levels, they're a powerful climate change gas. So the work that has gone into over the last 30 years or so in fixing the ozone hole and banning those HFCs has actually then had a positive impact on climate change as well. And so their findings have estimated that this is going to avoid somewhere between a 0.3 and 0.5 degree warming by 2100. So I mean, to me, this demonstrates that when as a world, as countries across the world, when we work together on solving something, we do have a very dramatic impact very quickly in relative terms, and that we can make positive changes towards reducing climate change.
Yes, certainly. I think, for anyone who's feeling a bit down about climate change and the progress being made, I think think back to the ozone hole, and that is certainly one big good news story regarding the environment. So we sort of recognized the problem and we turned it around, and we can do the same with climate change if we keep up the pressure on governments and everyone, basically.
Yeah, absolutely. I mean, it's showing here that, like, there's an example of people listening to the science, responding to the science, sustaining those policies, and then it having an impact. It's not rocket science that if we do these things and stick at them, they will have the impact we want to see.
Yeah, and good news to hear also that, like, we've also avoided potential other warming impacts from these hydrofluorocarbons, because we don't need more warming. We really don't.
No. Okay, so that's it for this episode. Thank you for listening. You can find a link to all of the materials we've referenced in this episode in our show notes. Next episode, we will be looking at level 3 of the Ziggurat, that the warming will be insignificant. We're also possibly putting together an episode unpicking some of the climate denial arguments offered by influential figures such as Jordan Peterson. If you want to know more about the Countering Climate Skepticism podcast, check out our website at ccspod.podbean.com. If you've enjoyed this episode and would like to support the show further, we'd really benefit from any reviews you've been put up either on iTunes or Apple Podcasts, as it's known now. So yeah, any reviews, get throwing them up there. Really helps us out. So that's goodbye from me, John Rainier.
And goodbye from me, Mark Prosser.
And I leave you with a quote from Albert Einstein: "Those who have the privilege to know have the duty to act." Thanks very much. We'll see you next time.